So I will do a simple Blinky project where I will have one LED flash, and then I want to make sure that it's flashed at the rate I want it to flash. I will add the ADC and to see how that is working. So let's start by going into the Microvision. Here we are, and I have no project open. So for today, I'm using a development board from Keil. This has a Cortex M4 from ST on it, a 407 IG. And then I have collected my U-Link Pro to it for debugging and for flash programming. So let's start. What do I need to start this project? I need to go within the pack installer and see that I have the right packs installed. So I open this. So I have from ST, I have an 407 IG HX. So when I choose this MCU over here, to the left, I will see what packs do I have installed, which are these green ones, and what packs do I have available, which I can install. So for this demonstration that I will do today, I only need the ARM Semsys pack and the Keil STM32 Cortex M4 device family pack installed. So I have downloaded them both before, and I can also see what versions of packs I have available on my hard drive. So this is now stored locally on my hard drive. So let's create a new project. So I will go to project, new project. I will go to MDK ARM. I will have a new folder called web for webinar. I will call my project Blinky because it's a Blinky. Open. So now I have to choose the MCU I have on my board. So I will choose the 407. I will click OK. Now the runtime environment will open. So this is the project manager where you will add and remove components. It's also where if you need to read on some component, you have links here that's marked with blue. So if I click this one, I will come to the documentation for the RTX, and this is, as you can see, stored on my computer locally. So it's a quite handy way of reading the documentation easily. So I want to do the Blinky. So for the Blinky, I need the LED. So I will choose the LED. Now Keil is telling me, okay, to use the LED, you will need the driver for the GPIO. Okay, so I will choose the GPIO. And then you need the hardware abstraction layer common. So I will choose this. As you can see, the LED is dependent on many things. So I can either go and click them one by one, or I can just click resolve, and you will see that it has been added for you automatically. I also am going to use the RTOS from Keil, which is called RTX. So I will choose this one, and then I will need the startup files. Then I click OK. So all these files that has been added here, you see you have the drivers, you have the configuration for the RTOS, and you have the library for the LED, was available to me within the device family pack from ST, which I have downloaded before I started my project. So the third thing I want to do now is to create a main file. So I will right click, click add new item to group. So I can either choose to do add a C file and call it main.c, or I can use the templates. Again, these templates come from the software pack, which we have been downloaded before. So I will go to Semsys, I would like to have a main function, so I will click add. Okay, I got my main function. Now I want a thread to control the flashing of the LED. So I will add this as well. I will use the user code template again, the semsys. This time I will choose a thread. I will call this LED thread, so I know what it is doing. So now I need to add some code to make this work. So I will do like this, and you can always use auto completion, just control space. So I will go LED on 0, delay for 250 milliseconds, LED off 0, and then delay for 250 milliseconds. And then I just need to import this file within my main file to start the thread. Like this. Okay. So now I will compile, press F7. Hopefully it will compile without any problem. We have to see. So there we go, 9 seconds later. So the next thing I want to do is download my binary to my target. So first of all, I have to select what debugger am I using. So I go into options for target. I go into debug. I will choose here Cortex, Ulink Pro Cortex Debugger. And as you can see, Microvision has support for a various number of other debuggers. I will choose this one. Then I have to check the flash programming algorithm, so I have it available. So I go into utilities, I click settings. So now, as you can see, the flash has already been chosen for me. This is because in the beginning, when I choose the MCU, Keil knows that, okay, if it's the STM32F407IGHX, it has a 1 megabyte on-chip flash, and it knows that this is the start address for it. So it will add it for me automatically. If it's not added for you, you can always click add, and here you will have some other flash algorithm and flash declared available. This is dependent on which software packs you have installed. So since I don't have so many installed, I will only get these few because this is the only MCUs I used so far. So we go out of here, we click OK, we click OK. So now let's load the binary to the target. Like this. And then we go into debug mode. Like this. And we click start, run. So as you can see in the corner down here, the LED is flashing, but it's flashing a little bit too quick. So I will show how to fix this as well. So I will fix the rate, and I will also show you how you can easily add the potentiometer, which is up here. So if the potentiometer is more than half its maximal value, LED number 4 will be on, and if it's less, LED number 4 will be off. So let's go ahead and fix the LED and add this functionality. So we will go outside of debug, and we will go to the configuration file for the RTX. So I run at the speed of 16 megahertz. So I will show you how to use the configuration wizard, which is this one. So as you see here, the speed is set to 12 megahertz, but it should be 16. So you can either edit the value in here, or you can go in the text editor and edit it over here. But usually this type of files is very long. It can be some thousand rows, so it would be very hard to know where this value should be edited. So this is where the configuration wizard comes in very handy. So if I edit it here to 16, press enter, and then you will see that it has been changed here as well. I will show you more in session 3 on how you can create this type of configuration wizard. So the next thing I want to do is to add the ADC. So I go to the runtime environment and I go to board support, AD converter. I click add. So now Keil is telling me, okay, you need the device, you need the driver for the ADC as well. So I will add this, and it also needs direct memory access. So I will add it. As you can see now, when I click OK, the files will be added to the project like this. So here we have the library and here is the drivers. So now I would like to add a thread that will take care of the ADC. So I will have already made this thread. So I will go to add existing files instead. Open. I will go to where the file is. I will mark it, click add, close. So as you can see, it has been added. So, and then I just need to add this file to the main file. Like this. Compile again. There we go. And then download to the target like this, and then enter debug mode. So let's start. Let's show you guys as well. So as you can see, the first LED is flashing slowly now, and if I turn the potentiometer, you will see that the LED go off, and if I turn it the other way, you see that it will go on. So we have succeeded in adding the ADC and doing the flash rate correctly of the LED. So let's say that, okay, we don't want the ADC anymore. How do I remove it? Well, it's very easy. What you do is you go into the runtime environment again, and then you just deselect the AD converter, you deselect the ADC, and you deselect DMA. So let's say now you have deselected this and you are uncertain of did the GPIO file, is the LED dependent on the GPIO file? Let's say you don't know this. So if you're uncertain, you can always check and try to deselect it. But then Keil will tell you, okay, since you have chosen the LED, you need the GPIO. So you can't remove it. So now you see that the ADC has been removed. I will just comment out this C file, make it a text file, and then I will just comment out the thread in here. Compile. Download to target. Debug mode. Run. So as you can see, the LED is still flashing, but it doesn't matter where I turn the potentiometer. The LED will not go on. So then we have successfully removed the ADC. So this was the first session. So today I have talked about the pack installer. What do you need to start your project? So you need the SEMSYS if you're going to use the RTX, and you need a device family pack for your MCU. So if you're going with F0 or from Texas or something, there is a device family pack for that as well. I've showed you how to use the runtime environment, how to add components and how to remove components. And I've showed you how to use the user code template, so you don't have to write everything from scratch. There is many things already done before, so you can get a head start. So this was about it for the technical. Next time I will talk to you about the debugger. I will show you more of it, what features it have, and different views and such things. So I just want to say thank you. So for technical questions, you can contact me, and for sales question, you can contact my coworker Niklas. I will unmute everyone now. So there it is. If you have any questions, if you have any questions, please ask them now, or you can contact me or Niklas later.
Hi.
Hi.
I have a question.
Yes.
You are using the ADC and you're using the LED, but where did you make the actual pin configuration? Because the LED and the ADC are connected on specific pins, right?
Yeah.
Or the potentiometer is connected to a specific pin. So where do they make that setup?
This is the perks of having an eval board. So I don't need to do this because this is something that has already been written to me. So when I choose to add the LED, it knows automatically how to connect it. So this is because of the software pack I downloaded, and then it has been in the settings. There is how it should be connected. So in session 3, so if you want to do your own software pack where you want to have the pin specified, this is possible as well. You just have to write it in your own software pack. So for instance, if you're going to use the like I2C or something, you can choose in the device. You have here how to choose the I2C. So you just have to enable it, and then you can choose the pin configuration for it. So yes.
I have another question then. You say that it's because you're using this eval board, so this whole setup is depending on knowing the eval board. But what about the RTOS? Do you always need an RTOS when you're doing like this? Because if you maybe have a smaller device, maybe you don't want an RTOS.
No, you don't need an RTOS. The only reason I use the RTOS is because I get the delay function very nice and easy. And since this is 1 megabyte of flash, I have a lot of memory, so I can afford to use the RTOS. But you don't need to use the RTOS if you don't want to.
What's the footprint of an RTOS like that?
I think it's depends on how much you're using, but I would say 5-6K. So it's a really small one.
Yeah. Okay. Thank you.
And we have a question from Musab. Can we have this video tutorial? Yes. I have been recording. I forgot to record the presentation, but I have been recording the technical, the demonstration. So yes, we will send you a link afterwards. Okay, so any last questions? Let's see, we got a question. Can we share this video presentation internally? Yes, you can share this video presentation internally, no problem. So if there's no more questions, hopefully I will see all of you next Wednesday, 10 o'clock Swedish time. I will go over the debug and trace and what you can do and which different views there are and a little bit about this. So thank you for joining today and have a good day.